Hello, my name is Maurice Olson, and I'm the Director of Security and Compliance for Yugabyte. And with me today is Sergey Stelmak, Yugabyte's Senior Director of Security Engineering. In this session, we're going to answer the most frequently asked YugabyteDB Anywhere questions related to security. If you have any questions during this presentation, you can put your questions in this presentation's chat window, and Sergey Stelmak will respond to you during the presentation. In this session, I'm going to give you a brief overview of YugabyteDB Anywhere and how this Yugabyte product offering differs from Yugabyte's other product offerings. After a brief overview of YugabyteDB Anywhere, I'm going to answer Yugabyte's customers' most frequently asked YugabyteDB Anywhere security questions. Specifically, we're going to answer, how does YugabyteDB Anywhere support encryption at rest and encryption in transit? What functionality and support does YugabyteDB Anywhere offer for encryption key management? How is authentication and authorization supported in YugabyteDB and YugabyteDB Anywhere? Does Yugabyte implement a secure SDLC to ensure products released by Yugabyte are secure by design? And finally, what types of security testing are performed on YugabyteDB and YugabyteDB Anywhere? So let's get started. What is YugabyteDB Anywhere? Well, YugabyteDB comes in three offerings. YugabyteDB, which is the heart and soul of Yugabyte's product offerings. YugabyteDB is an open source distributed SQL database built on PostgreSQL and Cassandra. YugabyteDB Managed is Yugabyte's hosted database as a service product offering featuring YugabyteDB. And the scope of this presentation, YugabyteDB Anywhere, is YugabyteDB packaged with our YugabyteDB management portal. YugabyteDB Anywhere gives you the simplicity and support to deliver a private database as a service at scale. YugabyteDB Anywhere is hosted by and managed by you. You can use it to deploy YugabyteDB across any cloud anywhere in the world with just a few clicks. And it also allows you to streamline the implementation of some of YugabyteDB's best security features. Since YugabyteDB Anywhere is the focus of today's session, all the screenshots presented in this presentation today are presented using YugabyteDB or YugabyteDB Anywhere. During this presentation, and when I speak about YugabyteDB Anywhere, I'll be referring to YugabyteDB Anywhere's management portal, and I'll refer to the database system itself as just YugabyteDB. Moving on to our first most frequently asked question, how does YugabyteDB Anywhere support encryption at rest? YugabyteDB supports both column-level encryption and cluster-wide encryption. First, let's examine column-level encryption. YugabyteDB supports both symmetric and asymmetric-based encryption for column-level security of data. But be aware that symmetric-based encryption is generally faster than asymmetric encryption. And the larger the amount of data that has to be encrypted, the more the performance difference between symmetric and asymmetric encryption will be noticed. Additionally, YugabyteDB uses PG crypto to apply column-level encryption, allowing you to select the type of encryption that will be used on the column. Ensure you use strong encryption algorithms like AES when using column-level encryption. Column-level encryption gives you the flexibility to choose which columns to encrypt and which key to use to encrypt each column. Just be aware that some columns can't be encrypted, such as columns being used for primary keys. Finally, and as best practices, consider encryption key rotations on a cadence that commensurate with the risk. And I'll talk more about encryption key rotation and management in a subsequent section within this presentation. But next up, let's examine cluster-wide encryption. YugabyteDB establishes 3 levels of encryption keys that are used in the process to implement cluster-wide encryption. Let's define the different types of encryption keys used in the process, and then we'll look at a diagram which visualizes the implementation of cluster-wide encryption. Starting from the bottom up, we have a symmetric key, which we'll call the data key for the sake of this presentation. The data key is used to encrypt the database files which store data. The universe key is a symmetric key used to encrypt the data keys, and the master key is used to encrypt the universe key. This process is also known as envelope-based encryption. Simply put, envelope-based encryption is the process of encrypting data with an encryption key, in this case the data key, and then encrypting the data key with yet another encryption key. Now that we have defined the 3 levels of encryption keys that are used in the cluster-wide encryption process, let's take a closer look at how the process actually works. Let's start off with the database files themselves, which exist on the database servers or T servers on the right-hand side of this diagram. Database files are encrypted with the data key, which we defined in the previous slide. For each database file created, a unique data key is created, which is specific to each data file. The universe key is used to gain access to the data key so that the database files can be decrypted at runtime. The universe key is stored in a catalog on the YB master instances as visualized in the boxes titled Master 0, 1, and 2. The catalog used to store universe keys is encrypted using the most recent universe key itself. The universe keys are protected with a master key, which is generated and stored in one of the various key vaults supported by YugabyteDB Anywhere, as represented on the left-hand side of this diagram. Currently, we support Azure, GCP, AWS, and HashiCorp key management services. One point I want to highlight in this diagram is that the universe keys are never stored decrypted on any file system. They are only stored decrypted in memory at runtime. You might be asking, where and how are the data keys stored? In this slide, I have a visualization of the format of an actual data file, which stores YugabyteDB table data. The data key is stored in the header of the data file encrypted using the universe key. Since YugabyteDB supports universe key rotation, we have to ensure we have a pointer to the correct universe key used to encrypt the data file, which is why we store the universe key UUID along with the data key. More on rotations in a subsequent section of this presentation. Please take note that the data keys are generated when data files are created, which can also occur during the compaction process. Our next most frequently asked security question is, how does YugabyteDB support encryption in transit? YugabyteDB supports TLS with strong ciphers to enable server-to-server encryption, which ensures that communication between Yugabyte T server nodes or communication between the T servers and the master servers are encrypted in transit. This level of encryption protects data communication that occurs within the boundaries of your security perimeter. Enable client-to-server encryption to ensure that communications between calling clients and the database backend is protected from unauthorized access and integrity threats. YugabyteDB does support mutual TLS or MTLS, which carries an authentication aspect to the TLS secure communication protocol, in addition to the encryption provided by standard TLS for data in transit. YugabyteDB Anywhere can create self-signed certificates on your behalf, or you can provide your own self-signed certificates for use with YugabyteDB Anywhere. Additionally, you can use third-party certificates provided by other public certificate authorities in order to facilitate encryption in transit. As I stated before, YugabyteDB Anywhere supports both server-to-server and client-to-server encryption in transit. In this diagram, I want to highlight the process flow, which details how certificates used for TLS are distributed to the database infrastructure. Starting from the left-hand side, you can see that certificates are managed by YugabyteDB Anywhere. YugabyteDB Anywhere acquires certificates from user configuration actions, as detailed in our previous slide, or you can use HashiCorp Vault to store your certificates, in which case YugabyteDB Anywhere will reach out to HashiCorp Vault and retrieve the certificate. Once YugabyteDB Anywhere has the certificate is deployed to all relative database nodes, which consists of both the masters and the T servers. The certificates are stored in a common location on all masters and T servers, as illustrated on the right side of this diagram. Next, what functionality and support does YugabyteDB offer for encryption key management? YugabyteDB Anywhere supports Azure, GCP, AWS, and HashiCorp Vault key management services. Universe and data key rotation is supported in YugabyteDB. In the next couple of slides, we'll focus on how universe and data key rotation is implemented in YugabyteDB. As I stated in a previous slide, the Yugabyte master servers contain a catalog of universe keys. The universe keys stored in the catalog are a list of all universe keys that have been used in the YugabyteDB infrastructure since inception. When you create a new YugabyteDB environment, you'll only have one universe key in the catalog. But as you implement and execute on key rotation, a new key is added to the catalog, and the catalog is re-encrypted using the latest created universe key. The catalog of universe keys is kept to ensure any data files which were created with a previous universe key can be decrypted at runtime. Rotating the universe key will result in a rotation of the data keys over time through the process of compaction. So how exactly does the universe and data key rotations work in YugabyteDB? To avoid having to re-encrypt all data on key rotation, we implement a process where we can have multiple universe keys active at one time. This is the reason why in the previous slide we maintain a catalog of universe keys that were used over the life of the established YugabyteDB infrastructure, and that we store a UUID of the universe key with every data file. Any new data files that are created using the latest universe key. Data files that were encrypted using a previous universe key will eventually rotate through the process of compaction as illustrated in the diagram below. In this illustration, we have three data files represented by SST1, 2, and 3. SST1 and SST2 were encrypted using universe key 1, and SST3 was encrypted using universe key 2, which is the latest universe key. In this example, you can see that SST1, 2, and 3 were compacted into a new file called SST4, which was encrypted using a new data key, protected by the most recent universe key, which is universe key 2. If you have any further clarifications that you need on this process, please feel free to add your questions in the chat window, and Sergey will be happy to answer your questions. The next most frequently asked question is, how is authentication and authorization supported in YugabyteDB and YugabyteDB Anywhere? First, let's talk about authentication best practices for YugabyteDB Anywhere. YugabyteDB and YugabyteDB Anywhere both support integrated authentication with a couple of differences. First, YugabyteDB Anywhere supports LDAP and OpenID Connect for integrated authentication with your IDP. Just note that only OpenID Connect integration supports single sign-on capabilities. In the context of YugabyteDB, you can use integrated authentication when appropriate to ensure users accessing YugabyteDB inherit your corporate password policy, and integrated authentication also allows you to centrally manage users accessing YugabyteDB. Just note that unlike YugabyteDB Anywhere, YugabyteDB does not support OpenID Connect at this time. And as a best practice, enable SCRAM-SHA-256 for password storage. The default is MD5, and MD5 is no longer considered a secure hashing algorithm for passwords. Finally, you can leverage host-based authentication to limit communication to the database environment through IP filtering. Next, let's talk about authorization best practices for YugabyteDB Anywhere. Authentication controls who can access a given environment, and authorization is the process of limiting access to certain resources within the environment after authentication has already occurred. Let's start with looking at authorization support for YugabyteDB Anywhere. YugabyteDB Anywhere supports role-based access, and you can use our role-based access to implement the principle of least privilege. Currently, Yugabyte Anywhere supports 4 roles: superadmin, admin, backup admin, and read-only access. In the context of YugabyteDB, YugabyteDB supports role-based access, and you can create custom roles and associate users to those roles within YugabyteDB. YugabyteDB role-based access configuration is beyond the scope of this presentation, but you can use the link provided in this slide to read more about role-based access in YugabyteDB. Although I won't be going into detail regarding YugabyteDB role-based access configurations in this presentation, I do want to highlight a unique feature in YugabyteDB called row-level security. With YugabyteDB, you can apply more granular role-based access to data by applying permissions on rows of data. Row-level security allows you to assign permission to specific user and group principals which restricts rows that can be returned by standard queries, as well as limits non-authorized principals from updating and deleting the affected rows of data. Does Yugabyte implement a secure SDLC to ensure products released by Yugabyte are secure by design? Yugabyte's security program is based on and consistent with the ISO 27001 security framework, ensuring that elements of security are built into our software development lifecycle. Furthermore, Yugabyte's approach to secure software development is consistent with the SD3+C methodology for secure software development. SD3+C stands for Secure by Design, Secure by Default, and Secure in Communications and Deployment. For those of you that are interested in privacy, Yugabyte's secure software development lifecycle also takes into account privacy by design principles to ensure adherence to data protection regulations like the GDPR. As part of our security program, Yugabyte maintains various security policies and procedures which define the standards in which we develop our products, such as our cryptographic security policy, which defines the acceptable uses of cryptography in our products, as well as change management policies and procedures to ensure a stage gate process to ensuring all of our security and quality assurance requirements are met prior to the release of any of our products. One of the cornerstones of a secure SDLC process is to ensure your engineers are trained to write secure code. It's much cheaper and more effective to have trained engineers writing secure code than it is to rely solely on tooling to retrofit security after the coding is complete. This is not to say that tooling doesn't have an important place within our secure SDLC. Yugabyte leverages various third-party tooling to scan Yugabyte code, as well as any third-party libraries, including open source libraries for vulnerabilities. We also perform vulnerability scans of any container technology used for the deployment of our products. To bolster our SSDLC, we have a public vulnerability disclosure program, and Yugabyte is a CNA underminer who can issue CVEs for vulnerabilities in Yugabyte products. We also have a security council, which is made up of security executives from large and well-known organizations, which act as a steering committee to enhance Yugabyte's overall security posture from a product, process, and policy perspective. Finally, what types of security testing are performed on YugabyteDB and YugabyteDB Anywhere? Well, in addition to all of the testing we do as part of our secure SDLC, we also leverage a reputable third party to perform in-depth security testing of YugabyteDB Anywhere and YugabyteDB, which includes application penetration testing, binary and runtime analysis, network and system penetration testing, source code analysis, network protocol analysis, and threat modeling. All of our secure software development processes, including third-party security testing, is audited by a third party in the form of our SOC 2 attestations. That concludes this session on answering the most frequently asked YugabyteDB Anywhere questions related to security. If you want to know more about YugabyteDB Anywhere or any of our products, you can review our documentation at docs.yugabyte.com, and you can also follow the evolution of our security program by visiting us at yugabyte.com/trust. Thanks for attending this session.